Introduction to long division. Okay, so we're going to use our long division strategies for this. We're dividing this by x minus 2. So our x minus 2 would go outside because that's what we're dividing by. 3x squared minus 4x plus 5 is going to go in the inside. Now, if we go back to what we were doing with our numbers, okay, with our numbers each time we would look and say, what would I multiply by to get close, and then subtract? What would I multiply to get close and then subtract? And we repeated that process over and over and over again. Well, we do the same thing here. We look inside. I have a 3x squared. What would I have to multiply x minus 2 by to get really close to 3x squared? A 3x? Does that make sense? If I multiply x minus 2 by 3x, would I get a 3x squared? Yeah, okay. Now, where am I going to write that 3x? Well, same way that we wrote numbers over our place value system, we're going to write numbers here. 3x is going to go over our x's column, just to have it in a nice spot. And what happens when I multiply 3x times x minus 2? I'm going to get 3x squared, and I'm going to get minus 6x. So it didn't quite match up, but it was pretty close. Why did I put the 3x above the 4x? Because it's sort of the same like term. It sort of matches up. Okay? And I now took this 3x and said, same thing we did with our numbers. When we got this blue 2, we said 2 times 13 is 26. Okay? Now we have a 3x, so we go 3x times this whole thing, which we have to distribute, right? The 3x is going to hit the x. That'll give you 3x squared. The 3x is going to hit the 2, the minus 2, and give you minus 6x. What did we do next in our long division? Yes, question. I wanted to get as close to this first term, whatever this is, as possible. So I said, what could I multiply x minus 2 by to get a 3x squared? And in order to get the 3x squared, I would have to multiply by 3x. Notice the 4x and the 6x, they didn't match up. But what we're doing as a process that we did similar here is we're getting rid of our biggest values. What happened here when we subtracted is we got rid of our thousands, and we were just left with hundreds left when we subtracted by 26. In a sense, we're trying to get rid of as much number as possible. So here, we're trying to get rid of that 3x squared. And if I multiply by 3x, I'm going to get 3x squared minus 6x. Our next step in long division was subtracting. Now this is the part that sometimes can be difficult because you have to subtract all of this from this. Now the first part's really easy because 3x squared subtract 3x squared is 0. So you can put a 0 there if you would like. And then negative 4x subtract negative 6x is 2x. And that's the part where you're going to make your mistakes with positive and negatives. Because you're subtracting negatives. Yeah, see? We're going to make that mistake. Because it's a negative 4 minus a negative 6. And so that's why I put brackets around it to remind us we're subtracting the whole thing. And then it would be 5 minus nothing, so there would still be a plus 5 there. And now we repeat this process. We now have a new first term, which is a 2x. What would I have to multiply x minus 2 to get a 2x? Just a 2. So I'm going to change color. I'm going to say I need to multiply by a plus 2. If I multiply 2 times x, I'm going to get 2x. If I multiply 2 times negative 2, I'm going to get negative 4. And we do the same process that we did before. Put brackets and subtract. 2x minus 2x, well, that's going to be 0. 5 minus a negative 4 is a plus 9. And that's our remainder. Because there's nothing we can multiply now to get a 9 because we have an x there. So it'll always be an actual number that's your remainder, unless there could be one where you're dividing by an x squared, and you could have an x plus something as a remainder. But for most of ours, we're going to have remainders that are numbers. Yes?
It would be 3x plus 2, 9 times 9 over x minus 2.
So we can, what this means, what we've done is we have been able to say that a couple of things. First of all, we took 3x squared minus 4x plus 5, and we divided it by x minus 2. It's equal to, right? When you do this, it's equal to 3x plus 2, but we have a remainder. There's a remainder of 9, and that 9 still needs to be divided by x minus 2. That's what we've done. Another way of thinking about this is that 3x squared minus 4x plus 5 is equal to x minus 2, which is what we're dividing by, multiplied by 3x plus 2. Because that's the whole reason we divide, right? To see what two things multiply. But it doesn't work out perfectly. We're off by a little bit. In fact, how much are we off by? We're off by 9, so we would have to add 9 to make it work. How is this like factoring?
Similar.
Similar, except we got a number here. If this number was 0, then we would have factored it perfectly. Does that make sense?
Yeah.
So this is going to lead into a strategy for factoring. Yeah, I know. So here's our next one. We're going to set this up with long division. X plus 1, 2x cubed minus x squared minus 2x plus 1. So if we recap, what are the important things that we're looking at? We're looking at our first term, which is 2x cubed. And we're asking ourselves, what would I need to multiply x plus 1 by to get 2x cubed? 2x squared. So I'm going to write 2x squared over my x squared column. And sure enough, when I multiply 2x squared times x plus 1, I get 2x cubed, and I'll also get plus 2x squared. We then subtract. This will be 0, and negative minus that will be negative 3x squared minus 2x plus 1. Because it's minus 2x minus 0 and 1 minus 0, so those ones, I mean, same language, you could say they just come down, but it's really because you're not subtracting anything away from them. That gives us a new first term, a negative 3x squared. What would you have to multiply x plus 1 by to get negative 3x squared? Negative 3x. So I'm changing color just to say we're doing the same process again and again and again. Right? If I really wanted to give you one that would take all class and get you really good, I'd start with 2x to the 3 million, and then you just have to keep going over and over and over again and just take pages and pages and pages of work.
That's it.
But it's the same thing again and again and again. So now negative 3x times x plus 1 is negative 3x squared, perfect. Negative 3x times the plus 1 minus 3x. And we subtract. Of course, this is 0, perfect. Negative 2x minus a negative 3x is plus 1x plus 1. So now we go through the process again. Now what's our first term? Now it's an x. What would you have to multiply x plus 1 by to get an x? By 1. So plus 1. And 1 times x is x. And 1 times 1 plus 1. And just like before, we're going to subtract. And what happens this time? 0. So when you get a remainder of 0, you just started to factor this. Okay? So what this means, I mean, this is pretty exciting. I know I'm excited. 2x cubed minus x squared. 2x cubed minus x squared minus 2x plus 1 is equal to x plus 1 times by, what did we get as 2x squared minus 3x plus 1. Perfectly factored. That does feel good. Are we finished factoring this? No.
Really?
Well, can you factor anything else? Can you see it?
Yeah.
This is the one that you can't do, right? The quadratics? Because once you factor it once, can you factor this one? This is 2x and x, 1 and 1, minus and minus, and it's factored now completely.
We have to equal to 0 too?
Not yet, because we were just said to factor.
It's pretty standard.
But now, if I made this equal to 0, because we factored it completely, you now know there's 3 answers. X could be negative 1, x could be positive 1/2, and x could be positive 1. That's what make that equal to 0. Yes?
So when you say how many times x plus 1 goes into the next term, like, for example,
Right here with the, I've always underlined it in the little black dots there, yep.
wouldn't it be how many times x plus 1 goes into x plus 1? Because you're saying, is then you're using...
Well, technically, you're looking at how many times does x plus 1 go into the whole thing at first. Just like when we were with our numbers, you said, how many times does 13 go into 2? It doesn't. Then we said, how many times does 13 go into 27? You weren't looking for how many times does 13 go into 2,748. As a starting point, you just said 27, you said 2. And so we're doing the same thing here. We're just looking at the biggest one and saying, can I get rid of that biggest one?
X plus 1 is bigger than x, so it doesn't fit into x.
It doesn't quite fit into that. And we might, in this time, depending on what number you get here, negative 3x squared is how much you went over or not enough. Yes?
What if you count like, you know, like the ones we've gotten, like 2x to the third?
Yeah.
You would multiply by 2x squared to get that. But what if you can't get like something like the exact amount?
If you can't get this exactly, well, you'll always be able to get it exactly. Okay? I mean, sometimes you might have to, like if this was a 2x here and this was a 3, then you would have to go to a fraction here. And we can do that. But most of the time, you will get nicer numbers, yes. At the very bottom where I wrote 0 or where I wrote it out? Okay, so this is your long division. This is your long division finished. This is what long division means, okay? What I was trying to show at the bottom, and I'll show you with an easier number. Let's do something really easy, okay? Let's take 16 and long division divide by 2. Ooh. Okay.
It's gonna take a while.
What's the answer? Well, you can't go no. How many 2s in 16?
1, 2, 3,
8.
5.
And then, oh, look at it, it works out. Okay? Well, what does this mean? This means that 16 is equal to 2 times 8. Learn something new every day. Right?
Why is it not 2 times 8 over 2?
So what this means, like this thing inside is like my 16, right? That is equal to x plus 1 times my answer. Just in the same way that 16 is equal to 2 times 8.
Are we supposed to write that down for every long division?
Sometimes it will ask you for something called the division statement. We'll learn the formalities of different things as we go. But this is just our introduction. This is just the introduction. Whew. Okay? So, in our introduction, we can see that. Do we want to write this down as sort of what are the steps that we did? Okay, number 1. What did we do? We looked at the first term. And I'm going to underline first term in dotted black. Just dotted blacks. I don't know if that's, how would you, black dots? There we go. Dotted blacks. With black dots, because that's what I did. I looked at the first term, and each of the first terms I have underlined with dots in black. Okay, we look at that first term and find what we would need to multiply, and I'm going to write x plus 1 in blue here, because that's going to change in each question. The x plus 1 might be a different number, whatever is in front, right? We look at the first term and find what we would need to multiply x plus 1 by to get that, right? Here's my first term, it's 2x cubed. What do I have to multiply x plus 1 to get 2x cubed? I need to multiply by 2x squared. Okay? Step 2, what did we do once we found that 2x squared? Multiply, and I'll write this in green because it changes each time. We multiply that 2x squared by our x plus 1. And subtract. So the color things can change depending on the question. Step 3, you just keep repeating this until you're done. So we did it for green. We subtracted. What do we get? We get a new first term. Dotted black line undered. Okay? I'm struggling. I should have just underlined it in black. It would be so easy to say. But you can't say underlined when it's not a line. Underdotted.
There you go.
Perfect. Okay. So now the negative 3x squared has been underdotted in black. Okay? So now we say, well, what would I need to multiply that x plus 1 by to get that negative 3x squared? Now it's a negative 3x. Multiply that negative 3x times your x plus 1 and subtract. We repeat again, and we keep repeating until we get to a number that you can't multiply x by. And we're never going into multiplying by 1 over x's or anything like that. And that's your remainder.